Hi, this is lesson number 2. We're going to do 3.2 graphs of proportional relationships today. Please put your name, date, and period on your paper. Always remember when you're listening to a video, it's important that you hear us and what we say. This is not a time to be listening to music. We will try to make it quick for you, so please just listen to us and we'll get through the lesson quickly. So we're going to start. Remember, a proportional relationship always goes through the origin. If you didn't know that, please make sure that you remember that. Goes through the origin. So you're going to write that down. And the origin is this corner of our graph. So every line that is proportional would go through that point. It also has a constant of proportionality. Which we call the letter K. There we go. Okay. Okay, so here's our graph that could represent a variety of different situations. It's asking us to, number 1, write an equation for the graph. So if you remember, we need to take our y terms and we subtract them, and that's our numerator. So start with a 28 and subtract 14. And our denominator is going to be 16 minus 8. And remember, this is our slope. So our numerator is 28 minus 14, which is 14. And our denominator is 16 minus 8, which is 8, which we can still simplify. Cut both of those in half. Half of 14, or divide by 2, is 7, and half of 8 is 4. So our slope is 7/4. When we write our equation, we simply put y over x is equal to 7/4. I'm going to take it out one step further, and I'm going to isolate y. I want to get y all by itself. So if you look, y is being divided by x, so I'm going to do the opposite of divide by x, which is to multiply by x, and that will cancel that out. Whatever I do to one side, I have to do to the other, so I also have to multiply that side by x. And what that leaves me with is, on the left, I have y equals. My fraction is gone. And on the right, I have 7/4 x. And this is how we want you to try to start writing your equations. Y is equal to 7/4 x, where 7/4 is our slope. Okay, on the bottom of your page, number 2 says to sketch a new graph of this relationship. So we're going to graph that down here now, and it's y equals 7/4 x. So we have y is equal to 7/4 x. So if I look at my graph and I look at my x variable down on the bottom, I'm going to pick, right in the middle, I'm going to pick 60. So I'm going to make x equal 60. And when I figure out what y is, when x equals 60, I'll have my point. So I'm going to substitute in 60 for x. So I'm going to have y is equal to 7/4, but instead of x, I'm just going to pick what I used.
Can I please have Robert Kelly to call teacher 4500 please put on campus? Thank you.
And I can turn my 60 into a fraction by putting it over 1. So I actually have 7 times 60 as my numerator, which is 420. And then my denominator would be 4 times 1, which is 4. So I have y is equal to 420 divided by 4. And 420 divided by 4 gives me 105. So right here is our ordered pair. We're going to use x and 60. X equals 60. So 60. And y is equal to 105. So that's my ordered pair right there, 60, 105. And I did not have to pick 60. I could have picked any of those numbers down on my x-axis, plugged it in, and figured out what y is. It's going to change. So I did 60 and 105, so I'm going to go over 60 and up to 105 and place my dot. And then, as we know, a proportional relationship always goes through the origin. So there's my 2 dots that I need to graph. So there's my line, best I can make it. So what I want you to do is look at your 2 lines. They both represent the same equation, y equals 7/4 x, but they look different. One of them is more steep. The other one is less steep, even though they represent the same exact thing. So please be careful when you are looking and examining your graphs to notice the axes, the x-axis and the y-axis in your graph, because changing those will change how your line looks. Okay, go ahead and you can flip your paper over, and please grab one of the purple transparencies and a whiteboard marker. You can pause this if you need to grab your supplies. What we're going to do is we're going to determine K, the constant of proportionality, for each of the 6 cards. I'm going to do 3, and you are responsible for the other 3. So I'm going to do A, B, and C. So starting with A, we have a point on the line, which is nice. So I'm going to label this point as, let's see, 24, 6. Okay, and remember that's a x and a y. So when we do our constant of proportionality, which one goes first? Which one goes as our numerator? The y. So we're going to put our 6 as our numerator and our 24 as our denominator, and we're going to simplify. 6 goes into 24, so we can divide both of those by 6. Divide by 6, divide by 6. So our numerator, 6 divided by 6 equals 1. Our denominator, 24 divided by 6 equals 4. So this is our constant of proportionality, or K, is equal to 1/4. Okay, let's try another one. Let's try B. Here's our point we're going to use. It's nice that they've already marked it on our line for us. And the point is 2, 6. And remember which one goes as our numerator? The y, the 6. So it's actually 6 over 2, which is a division problem. 6 divided by 2 equals 3. Okay, so for this one, K is equal to 3. Okay, make sure you put those on your paper. And I'll do one more for you. Oh, that's where you're going to put them. Okay, and then I will also do C, letter C. This one also has the dot on it for us, so it's 50. Right. 50, and then if I look here, it's halfway in between 150 and 200. So what number is halfway in between 150 and 200? 175. Okay, and remember which one is our numerator? It's our y, 175 and over 50. So what we can do right now is we can simplify this. We can divide those by 25 if we want to keep it as a fraction. So how many 25s are in 175? It would be 7. And how many 25s are in 50? That would be 2. So 7 halves. That's a simplified fraction. So you can keep it like that. You could also turn it into a decimal. 7 divided by 2, or we could have used 175 divided by 50. That would have given us 3.5. Okay, and a decimal or a fraction is okay for that. Oops. There it is. Okay, so 7 over 2, or 3.5. Okay, so you guys are going to finish the other 3 cards. I did A, B, and C. You're going to do the second row, D, E, and H. Okay, please make sure you do those. You can pause the video and do it right now, or you can do it at the end. Okay, moving on to the bottom is 2.3 different scales. So we have two large water tanks that are filling with water. Tank A is not filling at a constant rate. The relationship between its volume of water and time is graphed twice below on both coordinate planes. Let's look at those two lines. They don't look exactly straight, and that's because they're not filling at a constant rate. Okay, tank B is filling at a constant rate of 1/2 of a liter per minute. It is not graphed anywhere. The relationship between its volume and time can be described by the equation V is equal to 1/2 of T, where T is time in minutes and V is the total volume in liters of water in the tank. So I've labeled the two lines A and B, or sorry, I've labeled the two graphs, tank A, and we're gonna graph tank B. If you go down, it says sketch a line for tank B, graph it on both graphs. Remember what our relationship is? V equals 1/2 T. So we're gonna do the same thing we did on the front. We're going to pick a value for T, right? Instead of X, it's actually T. So for the first graph, I'm going to pick a value for T that's right in the middle. So I'm going to pick 1. So I'm going to let T equal 1. Okay, so my equation is V, or volume, is equal to 1/2 T. And I'm going to make T equal 1. Okay, so I'm going to substitute it. So I'm going to write volume is equal to 1/2, but instead of T, I'm going to put what I made it. I made it 1. Okay, so V, or volume, is equal to 1/2 times 1, which is 1/2. So here's my ordered pair right here. It's 1, 1/2. Okay, so I'm going to graph that. I'm going to go over 1 and up to 1/2. 1/2 is going to be 0.5 right here. Okay, so over 1, up 0.5. And it's proportional, so it always goes through the origin. There's my second dot. Okay, my other graph, again, I'm going to pick a number on my x-axis right in the middle, pick 60. So I'm going to use the same equation. Volume is equal to 1/2 T. And this time I made T 60, so I'm going to write T is equal to 60. And I'll substitute that in now. So volume equals 1/2 of T. So volume equals 1/2 of T. I made T 60. So V is 1/2 of 60. Volume is equal to 1/2 of 60. Well, I know 1/2 of 60 is 30. So here's my order pair. 60, 30. And this one was 1, 1/2. So I'm going to graph that over 60 and then up to 30. And again, it goes through the origin, so my other dot's going to go right there. Okay, I'll try and draw these lines for you. Maybe I can use a line tool. Okay, so there's that one. I can make it blue. Nope, I'll make this blue. Okay, and then there is that one. Okay. So, there's my two lines. And they both represent tank B, so I'm going to write that. And this one is a black line. Okay. So now we have some questions to answer. Remember, those two lines that we just graphed are the exact same line, but look how different they look when you graph them on different graphs. All right, so we have a couple questions down here. After 30 seconds, which tank has the most water? You can use either graph because it's the same thing. So it says after 30 seconds. So which one's going to show us 30 seconds? What's the one on the left, right? So 30 seconds is half of a minute. I got 1 minute right here. Well, half of a minute would be 0.5. 0.5 right here. So after 30 seconds, which tank has the most water? Well, tank B has a little more than 0.2 of a liter, and tank A has 0.6 of a liter. So which one has more? Okay, next question, number 7. At approximately what time do they both have the same amount of water? So when we're looking for the same amount of water, we're looking for where those two lines cross. It does not show us on the first graph, but it does on the second. Where do the two lines cross? At approximately what time? Okay, write that down for number 7. And the last one is number 8. At approximately what times do both tanks contain 1 liter of water? 1 liter. Well, 1 liter would show up over here on the left graph. 1 liter's right here. So, how much time for tank A? How much time for tank B to get to that 1 liter bar? Okay, so go ahead and answer those questions. You also have an exit ticket for the remainder of your points, and that's all Google Classroom. So please go to Google Classroom, answer the exit ticket, and complete the questions on your handout. Thank you. Bye-bye.